A ladder is being pushed towards a wall, so the top slides up the wall, as shown. Okay, so it must be being pushed towards here, and this thing's sliding up this way. How fast is the top of the ladder moving, given how fast it's being pushed towards the wall? Okay, this is going to be a related rate problem, because we're going to be given a rate of how fast we're pushing it up the wall this way, and we want to know how fast it's being pushed up this way. Okay, let's try to make our governing equation here, our governing geometric relationship. It is going to be Pythagoras theorem, right there. We're going to call this distance c, we're going to call this distance x, and we'll call this distance y, and we can extract that triangle right there. X, y, and c. The governing equation for this will be c squared equals x squared plus y squared. That is the geometric relationship. That relates the distances to each other. If we want to know the velocities, we will take the derivative, the differential operator, with respect to time, d by dt. So we will get 2c dc by dt equals derivative of a polynomial 2x times the derivative of the inside dx by dt plus derivative of polynomial 2y times the derivative of the variable itself dy by dt. Cancel out the 2's, so we'll get c dc by dt equals x dx by dt plus y dy by dt. This relates to velocity. So this had units of meters or inches or centimeters. This now has the units of meters per second. If we took the derivative again, we would get meters per second squared, an acceleration. We're not talking about acceleration here. We're just going to be talking how fast the velocity. So it can be assumed that we're going to be given a velocity here, and we want the velocity upstairs. Now, the ladder dc by dt is not changing because c is a constant. It's the certain distance. It's not changing. dc is not changing. Whereas x and y are changing. This one's going to get smaller, and this one's going to get bigger as I push it on the bottom. Okay, but c is going to be constant. So this guy actually goes to 0. So all we're really looking for now is we're looking for dy by dt, right here, dy by dt, as a function of dx by dt. So dy by dt, rearranging this equation, bring that over here and divide by y, will be negative x over y dx by dt. And there is the relationship. It does make sense it's negative because we're going to be pushing here as dx will be getting smaller. Dx by dt is not going to be getting bigger, it's going to be getting smaller. It's a little confusing here, but x is not getting bigger, right? X is getting smaller, meaning that dx by dt will be getting smaller. You're getting smaller x by over a certain time step. And that means that dy, negative, will be a positive. Dy by dt will be getting larger.